Let's have a look now at part 2 of the same question. So over here. Suppose we have an advisor, Wouter, who can predict whether Diedrich will accept this proposal. How much are we willing to pay Wouter in exchange for this information? Assume that 1 unit of utility is equal to 10 euros. Okay, so let's go back to the question and recall that we have these probabilities to work with. So over here, we are still uncertain whether Wouter is gonna say us to propose or not, but there's gonna be a benefit to us if he tells us so. So let's actually compute the expected utility from this advice. So the expected utility from this advice would be, we still have a 10% probability that things will work out and we get a 400 utility. But then we would pay for him, we would pay to know it. We would pay a certain amount. So let's call that amount X. And in here, X is the payment in utility. So we are giving up some utility to know that advice. Don't get too confused about that right now. We'll see how that works out in a second, because then we'll have to convert utility into money. But no need to get confused. So this thing plus the remaining probability, 0.9. But then what happens if Wouter tells us that we shouldn't send the payment, right? Because there's a 90% chance that Diedrich is gonna reject, and it could be that Wouter prevents us. So if we know that he's gonna reject us, we're not gonna go for it. We are not gonna send the paper, but we're gonna not send it. So we're not gonna send anything. And when we don't send anything, we know that our expected utility from no proposal is just gonna be 100. And we already saw that we would go for this certainty instead of going for the proposal, because 100 gives us a higher utility, which means that if we know that we shouldn't propose, we won't. So we would go for that. 100 we were not gonna propose, but then we also pay for that advice. Even in that case, we still have paid for the advice. So let's work out the math here. What do we have? 0.1 times 400, that's 40, minus 0.1 times X, plus 0.9 times 100, that's 90, minus 0.9 times X. Now if we add this 40 plus 90, that's 130, minus 0.1 minus 0.9, it's minus 1x. Now the question is, how much are we willing to pay? Well, how much are we willing to pay? We know that we would pay as long as we are equally off to our second best option. And the second best option is to not propose, because we saw that between those options of sending the proposal and not sending, we're better off not sending. So our best case, besides what we're trying to do here, is not sending the proposal. So the expected utility has to compensate for that, has to be the same. This has to be 100 units of utility. Now if we solve this, we can see that 130 minus X equals to 100. That's pretty simple to solve, meaning that X would be 30 units of utility. So we're willing to pay 30 units of utility, but those utility costs us money, and it's 10 euros for each. So that utility costs, in terms of euros, I should just write like that, 30 units times 10 euros each, so that would be 300 euros that we are willing to pay. Hope this makes sense, and we are done.